Hello, Microtronic fans. I'm happy to share another update with you regarding the retro-authentic Microtronic emulator, the one with the vintage bubble LED display, right? Like the original Microtronic. And I got a first batch of PCBs now, 10 of those, so I can produce some more. Previously I have used Oshpark for the prototype PCBs, and you get 3 there as a batch. And if those work fine, and that was assembled earlier and tested and was working fine, then I use another service for production of larger batches of PCBs. And I now found the time to assemble one of these from the first batch of 10, and yeah, it's working fine as well. So I have a little demo here using both retro-authentic Microtronics. They are booting up, showing their init message, and you see that I have two sets of cables here. So the inputs of this one are connected to the outputs of that one, and vice versa, and also the ground wire, right, is connected for a common ground. So this is to demonstrate 4-bit parallel data communication, bi-directional in both directions. So those two are going to talk to each other. For this I've prepared a little program and I stored it in the EEPROM. So let's load this program for data communication, and it is at slot 44. So and I'm loading that program from EEPROM into both the machines, right? So the EEPROM is that little chip here, the 24AC256. And the way that program works, as you can see here, so it's displaying 2 digits starting from register 0. So register 0 and 1 are being displayed. And then the next instruction is keyboard input into register 0, and the value in register 0 is being output to the digital ports, right? So over this wire. And then the other Microtronic is executing FD1, which means input from the digital inputs into register 1. And so this is also being displayed on the display then, and then we just loop, right? So now let's start both of those programs, and then you can see that a value which you input on one Microtronic is being displayed on the other. So if I put in a 5 here, next time I send maybe an 8, right? So there's one contact actually loose, it seems. So because I got a 4 here instead of a 5. Let's try that again. There you go. So if I put in an 8 here, and now I'm putting in a 9 here, so it did read an 8, and at the same token it is sending a 9 to that one. So next time I enter a key here, it's updating the display. So if I put in a 1 here, we should see a 9, 1 in the display. There we go, right? And then if I put in 7 here, what I should see is 1, 7, because this one is currently sending a 1. It's being read into the digital inputs. It's going to be displayed in register 1 here. And at the same token, if I enter 7 here, this one is sending 7 to the other side, right? So there you go, 1, 7. Now say I put in C, then I would expect 7C, right? So yeah, this is how that works. And yeah, a little demo of the digital inputs and outputs and bi-directional 4-bit wide data communication. Thanks for watching.